Good morning, students. In types of matrices, next matrix is lower triangular matrix. So in previous video we completed upper triangular matrix. Okay, if lower triangular matrix is nothing but a matrix, that means a square matrix is said to be lower triangular matrix if all the elements above the diagonal. Okay, if all the elements above the diagonal is 0, that means if aij is equal to 0 if I is less than j. So in general form of the matrix, this is the diagonal. So above all elements are in the form of aij, for which I is less than j. If all these elements are 0, then that matrix is called lower triangular matrix. So the example for lower triangular matrix is nothing but this one. So here this is 1 3 6 constitute the diagonal. So above elements all should be 0, but diagonal elements and below the diagonal elements may be 0, may not be 0. Okay, so maybe 0, may not be 0 0, but these if it is 3 by 3, these 3 should be 0. Next one. So minimum and maximum number of zeros in lower triangular matrix are n into n minus 1 plus n. Okay, this simplification here, n into n minus 1, maximum is n into n minus 1 plus n. This is equal to n square only here also. Okay, this is n square, this is plus n. Simplification gives, so n into n minus 1 plus n is equal to n square. Same like here also, what you get the maximum. So to get the maximum number of zeros we got n square only. Same, but why you get the maximum and minimum are for lower and upper same is here. So just here upper elements, here lower elements. Okay, so remaining same to same, procedure is same. That's why you get for maximum the maximum number of zeros in lower and upper triangular becomes to n square, and minimum number of elements in lower and upper becomes to, how you get here, n into n minus 1 by 2. Here also n into n minus 1 by 2. Same simplification. Here we are choosing lower elements are zeros, here we are choosing upper elements are zeros. So so elements will be same, that's why you get the same answer. Simplification will be same. Okay, procedure also same to get the formula. Okay, next one, triangular matrix. It is either upper or lower triangular matrix. That means a matrix is said to be triangular matrix if it is either upper or lower triangular matrix, any one of them. Okay, then that matrix is called triangular matrix. Next one, the maximum number of distinct elements in the triangular matrix of order n by n is n into n plus 1 by 2 plus 1. So in previous we discussed about minimum number of zeros, maximum number of zeros. Here the maximum number of distinct elements in the triangular matrix of order n by n is. Maximum number means, let us consider triangular matrix means here I am choosing upper triangular matrix. Let us consider, you can take lower triangle also, no problem, but I am taking here upper triangular matrix. So anyone you can consider. So in upper triangular matrix if you go for, so diagonal below all elements, okay, should be 0. Okay, remaining distinct means, here you are using distinct, not same. Distinct means remaining all elements should be different, no one is 0, then you get the distinct maximum distinct elements. If you want to get minimum distinct elements means here remaining also you should take zeros. Okay, so that's why, so maximum, minimum no one is asking for you, so maximum only they will ask. Maximum means So diagonal elements below should be all zeros. It is applicable for, if you take a lower triangular matrix, same you have to take. Upper all should be zero, diagonal and below the diagonal elements should not be zero, and all of them should different. Okay, so here you are choosing upper triangular matrix, so below diagonal all should be zero, and remaining all of them should be different elements which are non-zero elements. Okay, so for suppose if you take 2 by 2 matrix, so 2 by 2 matrix means 2 3 0 for I choose. So 0 is below triangle, diagonal, below the diagonal. So remaining all should be different. So here this is one element. So these two are different and this is also different. How you go for? See this one. This is 1. This is 2. All zeros will be treated as 1. So here only 1 0, that is 1. So 1 plus 2 plus this 0, 1. Next one. If you go for 3 by 3 matrix, this is, so 3 by 3, 1 2 3 0 4 5 0 0 6. So this is the diagonal. So above elements are, and all of them should be different. So this is for this one. These two treat as 2. These three elements, diagonal elements, treat as 3 plus 3. Plus all these zeros treat as only one element because all of them are same. So plus 1. So total 1 plus 2 plus 3 plus 1. See here you can generalize this formula. If it is 2 by 2, you get 1 plus 2 plus 1. If it is 3 by 3, 1 plus 2 plus 3 plus 1. That means if it is 2 by 2, sum of two numbers, two natural numbers plus 1. If it is 3 by 3, sum of three natural numbers, first three natural numbers plus 1. If it is n by n, sum of first n natural numbers plus 1. Sum of first n natural numbers formula is n into n plus 1 by 2 plus 1. So that is this answer. Next question. Diagonal matrix. So what is diagonal matrix? If it is both upper and lower triangular matrix, that is Aij is equal to 0 if I is greater than 0 and I is less than 0. So both should be. That means for the diagonal elements should be, that means for the diagonal elements, all elements above diagonal and below diagonal should be 0, and diagonal may be 0, may not be 0. We don't bother about that one. Just you go for, if it is triangular, that is diagonal matrix means for the principal diagonal elements, if you constitute the elements, for suppose it is 3 by 3, this 1 to 3 are principal diagonal elements. Okay, for these principal diagonal elements, all above and below should be 0, but these may be 0, may not be 0. We don't check that one. No need to check. Okay. So let us consider an example 1 0 0 0 2 0 0 0 3. Okay, so this is the 1 2 3 diagonal elements, below elements, upper elements, all zeros. So the matrix A is equal to, here capital A is equal to A 0 0. For suppose if you take a 3 by 3 matrix. Okay, if you take a 3 by 3 matrix, so A 0 0 0 B 0 0 0 C is denoted. This is the diagonal matrix, 3 by 3 matrix. Here if it is 3 by 3 matrix, so we have in the principal diagonal we have 3 entries. Okay, that diagonal matrix is shortly denoted by DIAZ, diag of set brackets A comma B comma C. If here 1 2 3 is there, diagonal of 1 2 3. For suppose example, next more example. So if you go for 1 0 0 0 2 0 0 0 3, so then how to write this in short form? Diagonal of 1 2 3. If you want to expand this one, just first you take this is first row element 1 0 0, we have to write. This is second row middle element 0 2 0. This is third row last element, that is 0 0 3, we have to write. Okay, if you have 4 by 4 also, you should, same procedure. Next one, the maximum number of distinct elements of diagonal matrix of order n by n is, this is also very very important. The maximum number, minimum number means only one. Minimum number means here all elements may be 0. Okay, these 3 elements should be 0, these 3 elements should be, all of them should be 0. Then minimum will becomes to only one element, that is 0. Okay, so nobody ask you minimum number, so they may ask you only maximum number of distinct elements of diagonal matrix of order n by n. See here, maximum number means according to diagonal matrix, diagonal elements, that means above diagonal and below diagonal, all elements should be 0, and diagonal elements should be distinct. Distinct means different. Okay, for suppose if you go for 3 by 3, what you get? 3 by 3. So these three should be different elements. So 1 plus 2 plus 3. Okay, this is 3 by 3. Okay, so 1 2 3 are three different elements. So remaining all these zeros and these zeros take as only one. Okay, that means if you want to get maximum number, if it is n by n, so all diagonal elements should be different elements. How many elements are there? N elements. So and remaining all of them are zeros only, so you take as one element. So total n plus 1, that is the answer for this one. Okay, total n plus 1. Next one. Scalar matrix. A diagonal matrix is said to be a scalar matrix if its diagonal elements are equal. That means a diagonal matrix, you know how it will be. In diagonal matrix, only diagonal elements will, except all diagonal elements are 0. That means in diagonal element may be 0, may not be 0, but remaining all elements are zeros. Okay, that is the diagonal. So a diagonal matrix is said to be a scalar matrix if its diagonal elements are equal. That means if you go for this example, so a0 0 0 b0 0 0 c. So when we call this diagonal matrix is said to be scalar matrix. So if a is equal to b is equal to c, that means here a, then it is called diagonal matrix becomes to scalar matrix. Okay, so that means one example you take. If you take 1 by 1 matrix, so in 1 by 1 matrix only one element, that is only diagonal elements. So if you take 3 4 5 whatever you can take. So next 2 by 2 matrix, if you take here minus 1 diagonal elements are equal, so remaining will be zeros. So if you go for this 3 by 3 matrix, this is one example. So all diagonal elements becomes to root 3 and remaining all are zeros. So that is aij is equal to for this one short form, for aij is equal to 0 if I less than 0 and I greater than j. I less than j and I greater than j. So I less than j means for this example, for our convenience. So this is all elements are zeros, this is all elements are zeros. This shows I less than 0 and I greater than 0. And all principal elements, the principal diagonal elements, how it will be? aij, I is equal to j. Yes, I is equal to j, these are the diagonal elements. So that means that I is equal to j, aij elements becomes to some scalar. Let us consider scalar means constant. Constant is equal to k you take. So that means here k means here root 3, here k means minus 1, here k means only 3. So if I is equal to j, this is the definition of scalar matrix.